Hey everybody, today I'm going to start one of the biggest but also one of the smallest projects I've ever done on this channel. Hopefully that'll make sense in a couple of minutes. But over the past few years I've been fascinated by the concept of modular synthesizers. So over the past year I've been doing some research and trying to figure out how I could get into modular synthesizers without spending a lot of money. Because a lot of what goes into modular synthesizers is the gear. And if you're any kind of gearhead, you know that gear can get really expensive really fast. So, what I was looking for was a project that was either DIY or open source to maybe bring those costs down a little bit. And what I found was not too long ago, Erica Synths, which makes Eurorack modules, put a bunch of their modules out as open source. So anyone can go and use those modules. They have the files for the PCBs, the wiring diagrams out there so that anybody could use them. I found a company that would make the PCBs because that's not something that I'm super comfortable with, etching my own PCBs and making those. So that was definitely something that I had to find someone to help me with. And they did an amazing job. I'll show you in a little bit. So this is going to be a build series on making some of those modules from the Erica Synth open source modules. So here I'm going to start with cleaning off the first PCB with a little bit of isopropyl alcohol. This just makes sure that all the contacts on the face of the PCB are clean and ready for soldering. If for any reason any of those contacts were dirty or had any like oil on them or something, the solder wouldn't be able to make a good contact. Now I'm going to start putting in some of the smaller components. These are diodes, and they kind of lay flat up against the PCB so that they stay out of the way. And I like to start with the smaller components and work towards the larger ones. That way, all the small stuff is out of the way when I start working on the larger components. Here's an example of a larger component. This is one of the dip sockets. It holds one of the integrated circuits, and just to hold it in place while I solder it, I'm going to put a little poster tack on it. These sockets don't have very long leads, so you can't bend them on the back to keep it in place. So you have to use something like poster tack, or I've used Scotch tape before to hold things like this in place while you solder. And I'm going to solder each corner. And at this point, you could take the poster tack off because it's being held in place by those two contacts. And then I can go back in and do the rest of the pins. Now that we've got all those sockets in, we're going to keep going. And next we're going to do some of the transistors. These look like half cylinders cut lengthwise, and they have 3 pins on the bottom, which you have to bend one of them out because the holes in the PCB are in the shape of a triangle. They're not all in line. So they take a little finagling to get into place. And then once those are soldered, we can go in and clip off all those leads. And then make sure you keep those in a safe place or they will get everywhere. 50 meters, drifting a little to the left, and 20 meters, and closing. 10, 5, steady, contact, and confirmation that trimmer pot has landed. Roger, Houston, this is Trimmer Pot. Now, this board has a big section on it right here that is for a switch, and it's a very special kind of switch. It is a 12-stop switch, and it looks like this. This one has a long shaft on it, but there are all these contacts on the bottom that will correspond to all of these holes on the PCB. Now, there are two ways that we can make sure that this is going to be going on the correct way. There is a raised key right here on the switch. It's just a bit of plastic that's been that's higher than the rest of the casing on it, and that lines up to the other PCB to this hole down there. So if we put the switch through, and we make sure that that is lined up with that key, we know that this is going in the correct place on this side of the module. But we still have all these contacts back here that we need to make sure are going in the right place. So on the back of this switch, I don't know if you can tell, but there are numbers for each of the contacts on the switch from 1 to 12, because this is a 12 contact switch, but we're only going to use 5 of them. And on the PCB, there is a very tiny number 1 right there. And that will help us line up the contact side of the switch to the circuit board. So let me get this placed, and then I will get it soldered into place. Once that's in the correct place, I put some poster tack on it so that it holds it in place while I solder, and then go around to the back side and start soldering all the connections on the back of the PCB. So the company I was able to get these PCBs from is called PCB Way. I'll have them linked in the description below. They provided all the work on manufacturing the PCBs. All I had to do was send them the PCB files, and they were able to get those to me real quick. They also offer other services like CNC, and they also did the faceplates for these modules, and they're made out of this anodized aluminum. They look great. You'll see those at the end of the video. I'll have their information in the description below if you want to go check them out. So this is the second board of this module. They get stacked on top of each other to save space. And this board has all of the controls that you will see come out of the faceplate on the front once it gets mounted into the rack. So this includes things like those potentiometers and then all of these mono jacks. So this is where either mono audio will come out, or you can put control voltage into the module. Here I'm just going to test fit the faceplate to make sure that everything is in the correct spot and nothing is getting in the way of the faceplate. So now I can go in and get all of those mono jacks tacked into place, and then come back and solder those. This is the faceplate for the oscillator. I also got these from PCB Way. They did an amazing job. The finish looks so good. They're anodized aluminum and laser etched for the markings on the front. So let me get all the washers and nuts for this because this one has a ton. So now you can see on the work table both of the PCBs stacked together with those headers. I'm getting all of the washers and nuts that hold the faceplate onto the potentiometers and the mono jacks, and getting those just finger tight for now to make sure that everything's in the right spot. That's what the oscillator faceplate looks like. And yes, I will have to cut down this post for the octave switch, but it's just plastic, so it should be easy. But now we can take this to the rack and see what it sounds like.